Okay, this is the final page for Math 31, Section 8.1, page 5. And we're going to pick up a little bit where we left off. We were looking at what happens when lines cross each other. So if you have two intersecting lines like this first picture here, here's the intersection, by the way. The angles that are formed across from each other are called vertical angles. And vertical in this sense is not the same as when you talk about something being straight up and down. Here it means across from each other when you have intersecting lines. So I've marked the two side-to-side vertical angles here. You might have a Walgreens on one side and a CVS on the other. For some reason, these two businesses like to situate themselves across from each other, direct, competition. But if this is a 30-degree angle, then this would be a 30-degree angle. And I'll explain that in a minute. But the other pair, I'm going to highlight in blue here, the other pair is across from each other like this. And these, in this case, this would be 150 degrees. And its matching one is across from it. The vertical angles are congruent. So let me highlight both pairs of these congruent angles. We have the 30s that are across from each other. I didn't mean for that to be quite that bold. And then we have the 150s that are across from each other, and vertical angles are always equal. They come in two separate pairs. The 30s are equal and the 150s are equal. Now let me explain the logic of it, and this might make some sense. Okay? So if this is 30 degrees here, actually I'm going to put a different measure here just to illustrate. Let's say it's 50 degrees. Okay? These two form a straight line, so they have to add up to 180. And as a consequence, we better have 130 there. So those are supplementary angles. Now the same can be said of this pair. They form a straight line. So this has to be 130 degrees. Otherwise, these two wouldn't add up to 180. And then we could do it once more here. Those are on a straight line, so they have to add up to 180, which then puts 50 right there. And no matter what I chose as my starting number, a similar logic would lead us to the conclusion that this pair of angles, they're called vertical angles, are the same, and the other pair of vertical angles are the same. Now, please bear in mind, I'm not using the word vertical in the same sense that I would if I said, for instance, that this line right here is a vertical line. That's not the same sense of the word. Okay, next we're going to use lines that are in the same plane. These two lines are written on the paper, and we're going to tell you that they go the same direction and do not cross each other. So if they're on the same plane, for instance, written on a chalkboard, okay, and even if you continued them forever, like if you extended them, okay, they would never cross each other. These are said to be parallel lines. So parallel lines. Probably the biggest, the most common analogy is railroad tracks. The problem with that is railroad tracks do curve sometimes. They go around a corner. They don't go like abruptly around a corner, but they're not straight. But if you were out on the prairies of western Kansas and they had a stretch of railroad that was just perfectly straight, then you would have parallel tracks. Okay, now when you have parallel lines, I'm going to highlight the parallel lines in this next one. It's M and N, okay? And I really actually have to say that. So I'm going to say M is parallel to N, and that's how you write M is parallel to N, okay? Then when another line crosses it, so you got this intersecting line, that, by the way, is the one that cuts across it. It's called a transversal line. So you have two parallels and a transversal. The transversal on this one I'm going to name K. So we have transversal K cutting across parallel lines M and N. when this happens, there's pairs of angles that are formed, and I got to kind of lead into it by teaching you some of the terminology here, okay? The angles that are inside the parallel lines are called interior angles. So angle 3, 4, 5, and 6. Those are between the parallel lines, which makes them interior. Well, the ones that aren't between the parallel lines are in the exterior part. So that would be 1 and 2 and 7 and 8. So kind of process of elimination here. Angle 1 and angle 2. Angle 7 and angle 8. Oops. Angle 8 are all exterior angles. Now, vertical angles are always congruent. We learned that above, so I'm going to give you some of those pairs. Angle 1 is catty corner from angle 4. So right here and right here. On that same corner, I could say angle 2 is congruent to angle 3. So I'll write that down. And then in this corner, you could have 6 equals 7 or 5 equals 8. Okay, so another set of angles that are equal to each other than the vertical ones, and this relies on having the knowledge that these two lines are actually parallel. So I wrote that up here. I said angle M and N are parallel, but I'm going to show you another way to indicate that on the graph that you'll see in a geometry class. They'll put an extra little arrowhead on here, and if it's got a matching number of arrowheads on the other one, you're telling me that those are like railroad tracks parallel. Now, it could be 2 on each, that would work, but those are parallel lines because of those extra arrowheads. If they're parallel, then there's some sets of angles that are equal. The first set is corresponding angles, okay? Corresponding angles, if you look at an intersection, will have the same description. So in this intersection, the top right angle would be that angle 2. And that corresponds to the top right angle from the other one, angle 6. So angle 2 and angle 6 are in the top right corner of their respective intersections. If this were kind of north, south, east, and west, it's a little bit like the northeast corner of the intersection, okay? And those will be equal to each other. So angle 2 is going to be equal to angle 6. And if the lines are parallel, you can conclude the other corresponding angles are congruent. So for instance, in this same intersection, angle 4 is in the bottom right. The bottom right here is angle 8. So angle 4 is congruent to angle 8. Now I'm going to put a mark up here for the next pair. Angle 1 is congruent to angle 5. Those are called corresponding angles in that case because they're in the top left corner of their intersection. And the one that's in the bottom left corner is the pair angle 3 and the other one angle 7. So if you look here, the bottom left number is at angle 3, and here the bottom left one is angle 7. So by corresponding, I mean they have the same description, bottom left, bottom left. Now, the next pair that's equal is the alternate interior angles. So we've got these interior angles right here, and we're going to pick one from each side of the transversal and one from each intersection. So that could either be 4 and 5 or 3 and 6. They're on opposite sides of the transversal, one from each intersection and interior. So what was that? Angle 3 is going to be equal to angle 6. Oops, let me write that correctly. And then angle 5 is congruent to angle 4. And all of those are interior angles are between the parallel lines. So now I'm going to do same side interior. Now what that would be is I have to stay on the same side, the same side of this transversal. So I have to either pick ones that are interior angles on the left side of that line or the right side. Well, here's the 4 that we're dealing with. The ones that are on the same side are 3 and 5 or 4 and 6. These are not the same. They are supplementary. So angle, let me go back up there. Angle 3 and 5 add up to 180. And then angle 4 and 6 also add up to 180. So you've got angles that are equal, and this last pair, they weren't necessarily equal. Their angle measures add up to 180, which makes them supplementary. So let me just give you an example here of what we would know. Let's say we actually knew an angle measure here was, let's say 80 degrees. Then that 80 degree mark could be transferred over here because these are vertical angles. That 80 degree mark is the same as this one down here because those are corresponding angles. They're both in the top right corner of their intersection. I could take that 80 degrees and transfer it down here because these are vertical angles. And this 80 degrees could transfer right there because they're alternate interior angles. They're on the opposite sides. So this is 80, it's equal to that one, this 80, it's equal to that one, this 80, and it's equal to that one, this 80. Now the same would be true if I went over to the other side and made a 100 degree angle over here. That 100 degree angle would be the same as angle 4 because these are vertical, across from each other on an intersection. Walgreens, CVS. Then that 100 degrees would equal this 100 degrees because these are on the opposite sides or the alternate sides of the transversal. These are alternate interior angles. And that angle 4 up there, 100 degree angle, would equal this one because they're both corresponding. They're in the bottom right corner of their intersections. So there's a lot of, in the end, what you would have is the following, okay? So let me see if I can get this to work here. Copy that and paste it. And then paste it again. And paste it again. And then I'll do the same with this one. And what you have is a situation where vertical angles are congruent, alternate corresponding angles are congruent, like these two, and then alternate interior are congruent, like those two or these two. And that's all I got for you folks. A lot to absorb in this section. Traditionally, this has one been the harder sections in the course. So spend a lot of time going over the vocabulary that we learned here.